8 raised to the power of x plus 2 raised to the power of x equals 130. Find x. Hi there, this is daily mathematics, and today we have this very interesting question here before us to solve. How do we find x? This is a very interesting equation. We have our solution here. So from here we have 8 raised to the power of x plus 2 raised to the power of x equals 130. So the first thing we can see here is that 8 is 2 raised to the power of 3 raised to the power of x plus then 2 raised to the power of x now equals 130. That's the first thing we can see. And so the next thing we can also see here is that from here we have, when you have a raised to the power of m raised to the power of n, it can be changed to a raised to the power of n raised to the power of m. The powers can be switched, one can be put in and one can be put out. And so from here we can make it 2 raised to the power of x, and then raised to the power of 3 plus 2 raised to the power of x, and then from here we have equals 130. And so from here we can bring this 130 over to the left hand side of the equation. We have 2 raised to the power of x raised to the power of 3 plus 2 raised to the power of x, then minus 130, then equals 0. We bring this over here, it remains nothing. That's why it's equals 0. So from here, what do we have? So from here we have 2 raised to the power of x raised to the power of 3, then plus 2 raised to the power of x, then minus 130 can now be split. 130 will now be split. Now you can see here that we have a number raised to the power of 3, and then we also have the same number raised to the power of 1. So we are going to make 130 to be split into a perfect cube, because this number is having like this is like a cube, it's having a cube. We have to make 130 to be split into a perfect cube, and then another number, and then that can all just be 125 plus 1 plus 5 then equals 0. So when we say 125 plus 5 is equal 130, so from here we have 2 raised to the power of x, then raised to the power of 3 plus 2 raised to the power of x, then minus 125, then minus 5, because minus times plus is minus, then equals 0. So from here we have, we can say, to just stop all these numbers, we can say let 2 raised to the power of x equal y, right? So from here we can have 2 raised to the power of x equals y. Wherever we see 2 raised to the power of x, we put y. So from here we have y raised to the power of 3, then plus y, then minus 125 minus 5 equals 0. And so from here we can now join all the perfect, this one with the perfect cube and this one with a single number. We have y raised to the power of 3, then minus 125, then plus y, then minus 5 equals 0. And then remember that 125 is perfect cube. Like I said, it's 5 raised to the power of 3. So we have y raised to the power of 3 minus 5 raised to the power of 3, then plus y minus 5, then equals 0. So from here, now recall that a raised to the power of 3 minus b raised to the power of 3 will give us a minus b, then bracket a squared plus ab, right, then plus b squared. That's what we're going to use today again. We're going to use that rule. So from here we have y cube minus 5 cube will become y minus 5 bracket y squared plus 5y plus 5 squared, then plus dy minus 5, this one here, then equals 0, right? So from here, what do we have? From here we have 5 y minus 5 here and y minus 5 here common, so we can bring y minus 5 since it's common, and then when we bring it out from here, from this side, we have this one left. That's y squared plus 5y plus 5 squared, and then when we bring it out from here, what is left? Plus 1. When we factorize it from here, 1 is left, then equals 0. And so from here, what do we have? From here we have y minus 5, and then we have y squared plus 5y plus 5 squared is 25 plus 1 26. That'll be plus 26 equals 0. So from here we can equate each bracket with the 0. We have y, right, minus 5 equals 0, and y squared plus 5y plus 26 equals 0. So from here, y minus 5 equals 0, we know y equals 5. Y equals 0 plus 5, y equals 5, right? And so for the second value, y squared plus 5y plus 26 equals 0, we know that this is a quadratic equation. We know that this is a quadratic equation. So from here, what do? We use our quadratic equation formula. But before we use our quadratic equation formula, we can actually find out the values of what we're going to get, if it's going to be positive or negative, by using the formula delta equals b squared minus 4ac. Now, what does this formula help us to know, or help us to work out? It helps us to know if what we're getting is going to be a positive root or negative root. So from here we can be able to know, so I will not be able to, will not waste our time with our solutions and all that. So from here we know a is 1. A is the coefficient of letter squared, that's y squared. A is 1. Here b is 5. B is the coefficient of a y, and then c is 26. So from here, b squared, that is 5 squared, minus 4 times a, that's 1, times c, that's 26. So from here we have 5 squared, that's 25. Then minus 4 times 1 times 1, 26 is 104. Then delta equals minus 79. So delta here is minus 79. So having gotten delta here, so from here we can see what we're going to be getting when we use our formula method is going to be something like root minus 79 over maybe 2, or over 2, or something like that. Something like that. That we're going to be getting. So that will be negative root, and which is not going to be needed. So this equation here is cancelled. So we'll come back to our original equation where we say phi y equals 5. But remember we said 2 raised to the power of x equals y. We were asked to find x for the question, but here we are finding y, and we say 2 raised to the power of x equals y. So from here we say 2 raised to the power of x equals y, and then y is 5. It means 2 raised to the power of x equals 5. And so from here, what can we do? We can take natural log of both sides. Can decide to take the natural log of both sides. Log raised to the power of 2, log of 2 raised to the power of x equals log of 5, natural log. And so from here, remember that when we have a log and it has a power, the power will go to the other side. That means here we have x log 2 equals log 5. Right, so remember this, when we have power here, the power cross will come over to this side and become like a coefficient. So from here we have, want to get the x, we have to cancel, eliminate anything standing, as divide all through, divide both sides by the coefficient of the letter. So here we have log 2 cancels log 2. We have x equals log 5 in base 2, right? Log 5 in base 2. That's, remember, when we have log a over log b, the answer will give us log a base b in base b, and this can also be changed back to this. It's just something like that. So this is our value for x, and the value, the numerical value for this is 2.32. The numerical value for this is 2.32. So from here we can check our equation. Can use the algebra calculator. The original equation was 8 raised to the power of x plus 2 raised to the power of x equals 130. So from here we can bring it here. 8, let's bring it over here. So from here we have 8 raised to the power of x plus 2 raised to the power of x equals 130. So remember, x is equals 2.32 that we got here. So we'll have it here. So we have 8 raised to the power of 2.32 plus 2 raised to the power of 2.32, then equals 130. So h to the power of 2.32 is actually going to give us some decimal numbers, but when it's rounded up, it will give us 125. And this, when we solve it, when we work it out on our calculator, it's giving us 5 point something, 5.0 something like that. And then when it's rounded up, it's giving us 5. And then we know when we add 125 plus 5, does it give us 130? Of course, it gives us 130. So this brings us to the end of the question. Please don't forget to like the video, subscribe to the channel, and don't forget to leave your genuine thoughts about this video. Thank you very much.